In this video, we're going to talk about the reactions of amino acids. We're going to talk about their reactions with acids and bases, and we're going to talk about the reactions to form esters. And we're also going to go on to talk about amino acids with different R groups and in different types of formula, which they'll use to confuse you in exam-style questions. And we'll also, in part 2 of this video, go over the exam-style questions related to amino acids. So the amino acids you're going to have to deal with are going to be alpha amino acids. So an alpha amino acid just means that the carboxylic acid that we have over here is separated by one carbon from the amine that we have over here. So an amine and a carboxylic acid. If there's only one carbon there, it's an alpha amino acid. Then on that carbon, you have an R group. The R group can be one of 23 different R groups to change it from one amino acid to another. But let's look at this nitrogen here that I've coloured purple. That purple coloured nitrogen is to indicate that it can act as a base. So the nitrogen in the amino group acts as a base and donates a lone pair of electrons. It accepts a proton when reacting with an acid, but what does this actually look like? So let's put the lone pair of electrons on and give you the H. We then take the lone pair of electrons to the H and form a dative covalent bond. So here is our dative covalent bond formed as a result. That means both electrons come from the nitrogen only, and it means there is one too few electrons here because remember the H has no electrons whatsoever, so we're missing one electron and therefore overall you have a positive charge. So remember, if it's an exam answer, why does it act like a base? Because it's donating that lone pair of electrons and accepts a proton. So let's have a look now at the carboxylic acid acting as an acid, and does that through donating a proton. So let's put our proton up. There is our proton. And our proton has left and been donated, separated from the carboxylic acid. Because it's separated from the carboxylic acid, it's donated that proton, it acts like an acid. Now, if we put that back on again, and we show you our alpha amino acid. Now, the last thing we're going to show you is something called a Svita ion. The word Svita ion is not really going to be used in the exams, hence we haven't written it, but written it here, but we've written it up there. That Svita ion is when the H from the OH, from the carboxylic acid, donates and then comes over here and then bonds as a H with the N. And we're going to show you that now. So there you go. You've got that positive charge here. You've got the negative charge there because it's lost its proton. You've got the positive charge here because the nitrogen has too many protons and too many bonds. Okay, and overall this is still neutral. And that is a Svita ion. And alpha amino acids and all amino acids are able to do this. And you may be asked at some point to draw this. Okay. Now, how do we change the amino acid? So we go back to our normal amino acid, and here we have our normal structure of our amino acid, and we're going to start changing the R group. So let's change it for our simplest one, which is an R group of an H. That means you have glycine. So different R group, different name. So glycine, where R is equal to H. Let's look at a different one. This time, we've got alanine. And look carefully, where is your R group? Where is your R group? Which on the central carbon, you've got one H, and then you've got a CH3. So your R group is this CH3 here. So you have to get used to recognizing the R groups and being able to put the R groups back on. So there is our R group, alanine, where the R group is CH3. Now we're going to go to histidine. I want you to try and look at this yourself. Try and think, where is the R group? What is the R group? You might have to identify it in the exam. All we have to do is look for the amino acid. The amino acid is here. This is our central carbon. So this part here is our amino acid, which means all of this part is our R group. So let's just break that bond there. Okay, and our R group would be this. Okay. Now, it is well worth you practicing that. Just pick any amino acid whatsoever and try and figure out what its R group is. You can do the R group in any type of formula you want, but I'd recommend if it's a ring, you just draw it in skeletal formula. It's a lot easier. So let's go to the next reaction, which is with acids. we've got a monoprotic acid here, hydrochloric acid, that's going to donate a proton. A proton is going to react with a base. So we know that this is a base where our nitrogen is. We've got a lone pair of electrons that can do a dative covalent bond with there. But what happens to the Cl? Well, let's have a look. So you've got your amino acid again, and let's look at what happens with that proton coming across and making that dative covalent bond with there, and then what happens to the Cl? So your H is going to go across here, as we've said. Your Cl is going to go to be a Cl- ion, which means you've got a salt producing here. And you sometimes draw this NH3Cl. Okay. Now, that means you've got an ionic bond. Again, this is going to have a higher melting point than it would normally because it's got an ionic bond. And that is the normal kind of salt you will create when you react with an acid. We now go on to the reaction with alkalis. The reaction with alkali is as it would be with any normal kind of acid-base reaction. Acid-base goes to a salt plus water. So our base here, our alkali, our OH will react with our H to create that water. Okay, and we'll get a sodium salt as well. So let's look at this being made. So your sodium's going across, and you can see that your sodium here is forming another ionic bond with the O-. Okay, so because it's an ionic bond, again, higher melting point than we normally would do. Okay, and you've got that water. So again, what type of reaction is this? Think about it. What type would you say? Okay, so neutralization reaction, because you've got this water being produced and you've got an acid reacting with a base, and there's your water being produced in the OH and the H here. And that's how you do a reaction with an alkali. Just remember, sometimes they don't include the Na, they'll just call it OH-. If that is the case, you don't put the Na on the final product, you just have O- and have a carboxylate. So also, what you've noticed is sometimes, and you can see over here with corn, if I just come back over here, you'll see that the plus and the minus is not there anymore, because sometimes you'll just see it as ONA and not as O- and Na. And if it's written like that, that's written just to confuse you, because what they're trying to get you to miss is the fact that it's an ionic bond, and if it's an ionic bond, higher melting point.